Swayam Prabha. Digital India. Educated India.
So, our present topic is variance length curve. So, in addition to the spectrogram basically identifies the periodic fault, and variance length curve also can identify the periodic fault as well as overall the quality of the product, overall irregularity it shows. Now let us try to understand the generation of variance length curve. Now, where suppose this is the yarn or any fibrous strand sliver. So, here the yarn is of total length of yarn is shown here, and this is the mass or diameter variation. Now, let us try to understand this is a material. Okay. Here if we cut this strand say sliver in a certain pieces, different pieces of certain length, this is the cut length. At the different cut length, now we are taking the mass. So, M1, M2, M3, M4, and then what we do? We are taking the CV percent, okay, and then square of CV we are getting the variance. So, if we do in between this cut length, so we will get certain CV percent of V1, and instead of this for same material, suppose we are increasing the cut length, instead of suppose it is 1 centimeter, we are doing it for 10 centimeter we are cutting. So, whatever variability will be there in this 10 centimeter cut length, so variability will be reduced, and as we go on increasing the cut length, so variability will be further reduced. So, if we plot in the x axis the cut length and y axis is the variance, in that case, so ideally if the cut length is say this is the material, if cut length is suppose tends to 0, almost to 0, very small, say 0.0001 millimeter, if we can cut the strand and take the mass of individual that cut length, in that case it will the variability will be maximum variability, because it will take care of all the variation in that. And when we go on increasing the cut length, so and take the average of this and next cut length take the average, then it will be the variability between, so M1 and M2 average will be much lower, and if we go on taking the large number of data and calculate the standard deviation CB percent and variance will be reducing. So, as if it is said 0, at 0 theoretically the variance will be maximum, and as we go on increasing the cut length the variance will be reducing, and this is known as the variance between the cut length. This is variance between the cut length. Okay. Now, another concept is that the and variance between length, and between length, and in short we call it as BL curve. Okay. This is one form of variance length curve. Another case, suppose this is the our product. Now, what we are taking? We are trying to take the what is the variability here within this length. Variability in this length, that means it is actually taking care of large variation, smaller diameter, large diameter. So, within that length, say 1 meter length, the variation is very high, and gradually if we try to reduce. So, we want to know the variation between say 1 centimeter length. At that length, when we are talking about the either 1 centimeter here or 1 centimeter in this zone variation will be much lower than the 1 centimeter. That within that length, and if we go on reducing, and when it is close to 0, the variability will be minimum. So, that means here variability increases with the cut length, and this variation is known as the variance curve within length, or in simple term VL curve. So, there are two types of curves, one is BL and another is VL curve. Okay. So, between length, the mass of each length L is measured and CB percent is calculated. L varies subsequently, we change the L, and the CB percent is the CB between the L yards length and given by the symbol CBL, or in short BL. Okay. Now, this is the shape as I have already discussed, and within length CB of each individual length is determined, and the mean of CB is calculated as the CB percent within L length, and the symbol is CVL, and in short it is a VL. Okay. And the shape of the curve is this, and if we add BL and VL, we will get the total curve. So, BL will be this type of curve and VL is this. So, if we add, we will get a total variance, and which is constant for the whole any cut length. So, VT will be BL plus VL, and if we take the x axis as a logarithmic scale, the ideal case the BL between length, it will be a straight line. So, in actual in industry, the BL is considered, BL is taken, which is termed as in general variance length curve, where we use the variance between length and which has got practical significance. Now, let us try to do one numerical. The nature of BL curve is y equal to mx plus c. Y is variance, which is square of Cb, and x is the log of cut length in centimeter. So, the nature of BL curve will be like this. So, here it is a log of cut length and this is the variance and this is the shape. The variance is 10 with 10 centimeter cut length. So, here with a 10 centimeter cut length, variance is 49. So, this is 49 at this 10 centimeter cut length, and 1 meter cut length, the variance is 36, and this is straight line which is given. What will be the approximate U% of that yarn when tested in evenness tester? Now, this is 10 centimeter, in U% is the value which is calculated based on the cut length 1 centimeter, and here it is a 10 centimeter on 1 meter is given. Now, let us try to calculate the variance between length with 1 centimeter cut length. The solution from the BL curve, variance is given by 10 log cut length plus C. So, we have to use this relationship V equal to CV square. Now, from the given conditions, so 49 equal to m log 10 plus C, which is m plus C. So, m plus C equal to 49, and second condition 36 equal to m log 100 plus C, so 2 m plus C. So, we can, if we solve these two equations, we will get the values of m and C. The solving, we are getting the value m equal to minus 13 and C equal to 62. So, in Worcester evenness tester, the count, the variation is that cut length here is 1 centimeter cut length. So, that we have already discussed 1 centimeter cut length. So, for 1 centimeter cut length, we have to calculate the variance. Now, let us see. So, variance or CV square is minus 13 m log 10 1 plus 62. So, here log 1 is 0. So, it will be variance is 62. So, CV will be under root 62. So, CV we get 7.87. So, CV in the Worcester tester we get. So, the question asked was what is the U percent? So, CB percent U percent approximate relationship we know. So, 7.87 divided by 1.25 will be approximate U percent from that relationship. So, we get the Worcester percent 6.23. Now, another numerical or similar numerical here, the nature of BL curve is y equal to mx plus c, y is variance and x is log cut length. The variance with 1 centimeter and 1 meter are given 64 and 36 respectively, like other earlier one. What will be the expected count CB of yarn? So, we want to measure the yarn count CB. When the yarn count is measured based on the 120 yards of lee. So, we have to calculate the yarn count CB. So, we will do in the similar way, but here only the cut length will be 120 yards. So, 120 yards we will have to convert. So, the rest other system will be same, process will be same. Now, let us see solution. Variance is given by this relationship, and now first our idea is to, with the given condition, we have to calculate the value of M and C. So, M and C from the given condition we have calculated, M is minus 14 and C is 64. So, this is calculated. Now, for count CV, the measurement, the what we do, we use the cut length of 120 yards. Now, let us convert this 120 yards to centimeter, because in the equation the relationship, it is centimeter is the cut length given. So, 120 from 120 yard to inch 36 multiplied by 36, then inch to centimeter 2.54 we multiply. So, we get 10,972.8 centimeter, and then what we are using this and this value of cut length in the given relationship. So, M is minus 14 and C is 64, and this is the cut length. From the equation what we get, the variance is 7.436 and CV percent will be under root of that 2.73. So, therefore, the expected count CV of the yarn is 2.73%. So, in this way we can use the, if we know the relationship, we can calculate the count CB or U percent. So, the variance length curve is a graphical representation of the coefficient of variation against the reference cut length. So, that we have seen when the variance length curve is actually variations prevailing at different cut length are simultaneously represented graphically, that we have already discussed. Representation of cut lengths are, this is the, these are the cut lengths. So, if we take the cut length L1, so we will get for the same material we are taking a different cut length. So, L1, L1, L1 is the cut length and this is L2. So, L2 is actually the distance is twice the L1. So, if you see L3 is the fourth time of L1. So, in this way we are taking different cut lengths and then we calculate the variance and then we plot. So, typical variance length curve where we plot in this we get almost straight line where the x axis is in the logarithmic scale and y axis is the variance. So, we can identify the fault whenever the fiber strand becomes faulty, either due to inferior quality of material or due to improperly optimized process or due to faulty machinery. So, these are the different causes of or reasons for the fault. So, inferior quality of material. So, faulty machinery we can identify through the spectrogram, but improper optimization and inferior material, that spectrogram will not be able to identify. Then what then coefficient of variation becomes high at cut length corresponding to source fault. When the faulty machinery is there, then CV% of that portion will be high. So, if we see, we can also identify the, this is the normal one and defective one is typically high, and if it is this type of fault. So, at this cut length, then we can assume that there will be some fault due to the machinery. Therefore, the variance length curve of a strand with fault is always lies above the curve with a fault free strand. Okay. Spectrogram, the main problem is the spectrogram cannot identify the difference between fault free and faulty yarn until and unless it is it has got some periodicity, but the this variance length curve will always give this, it will be higher. The faulty material, the variance length curve will be at the higher than the normal one, and it also measures the periodicity where there will be sudden increase. So, it lies above the fault free strand. This is the faulty strand, this one is the fault free strand. Now, control on draw frame sliver quality is extremely important. So, sliver quality, because Ritter calls draw frame as money back machine. The idea of money back machine is that it is a, here we can easily control the quality, and if we can control the quality at draw frame stage, then we will achieve very good quality, but if we cannot control here, then the fault will continue at up till the yarn stage. Cruisler says that no other machine can achieve such great improvement with a little investment. So, draw frame relatively a simpler machine, and if we can control the drafting zone properly, so then we can improve the quality to a great extent. The draw frame has strong influence on subsequent process. If draw frame has actually that it creates some fault that cannot be minimized, that cannot be eliminated in subsequent process. The expected function of draw frame are equalizing, blending and dust removal. So, we can do the equalization by doubling, we can also blend there and also dust removal during the drafting. So, yarn U% can never be better than the drop frame. So, the yarn CBU can be actually improved at the drop frame. The defects passing the sliver goes directly to the yarn without any rectification, but before drop frame if there is anything we can any defect, any non-uniformity we can control at the drop frame stage. Now, there are different factors which affect the sliver CB, diameter of top roller which actually the controls the nip area, hardness of top roller. So, if it is very hard, then the pressure will be more, it may damage the fiber, and if it is soft, so that the contact area will increase, that is important. Surface characteristics of top roller. So, because as we have seen that surface characteristics is important to change the frictional coefficient. Fluting on the bottom roller. So, flute type is important because it has to increase the friction without damaging the fiber. From form of fiber guiding device such as the pressure bar, pin bars, pin aprons, condenser. So, that this actually this controls the fiber guiding. Clamping device, level of draft and draft distribution. So, as we say, we have seen that if we change the draft, that will affect the drafting force. So, draft distribution is important. So, what do we need to do to control the quality in the drop frame section? Investment is low here, but improvement is high. So, we can have higher improvement with a lower investment. So, one should concentrate on improving the actually the quality of drop frame. So, in that case we will achieve better quality. Many of the yarn properties like evenness, count variation depend on the drop frame sliver, because it after drop frame sliver there is no other process beyond drop frame which can control the, we can reduce the yarn irregularity. Okay. So, electronic and computer controlled systems are there to control the count variation, like a change in one tooth of draft change pinion at drop frame affect one position where it affects 108 to 113 positions of speed frame, 400 to 500 positions in spinning, ring spinning. Okay. So, that is one tooth is, that is a actually that type of draft is there. Contribution of process on yarn count variation. So, 50% contribution is there of drop frame on the yarn count variation. So, it is a maximum contribution is there. If we can control properly at the drop frame stage, the yarn count variation can be improved. So, 13% in blow room and carding, 20% in speed frame, 17% in ring frame. So, that we can see the majority of contribution of count variation in the yarn is by at the drop frame stage. So, it is not only the drafting arrangement like the dispersal of pressure on the fiber in the drafting zone, but also the pressure rollers or pressure bar or roller to keep the check in the movement of short fibers. So, what we have discussed till now, this is the drafting rollers that controls the fiber. But in addition to this, the pressure bar or pressure rollers are there, which controls the drafting roller movement, drafted fiber movement, that is the movement of the, this is pressure bar which controls the movement of the floating fibers, and thereby the sliver unevenness is checked, and this is further supported by the weighting by the spring, pneumatic, and so we can have different types of weighting system. The flutes on the roller makes more meaning to the control. So, here in the bottom roller, to control the fiber movement, the fluted rollers are used, and inclined flute. There are two types of flute, one is straight flute and another is spiral flute or inclined flute, that gives a better and continuous grip. In straight flutes, that what happened, the continuity is not there, sudden actually sudden change. So, sometime it is gripped and in other time it is not gripped. So, when it is inclined, the continuous grip is there. So, the special features are crumbling of weft at draw frame heads leads to long thick places. So, that we have to see. So, here if the web, the drafting web is crumbled at the draw frame, then it will create long thick place, and the stretching of the web, that if the web is stretched during drafting, that will create long thin places, that we have to control. Obviously, the distance between the calendar roller and front roller need to be shortened, because if the, this is the calendar front roller and here is the calendar roller. So, if it is actually long, then it will stretch the wave, and which will create the thin places, long thin places. So, here you can see this is calendar roller, okay, and here if there is a crumbling happen, so that will actually accumulate the web and it will create long thick places. So, modern draw frames have taken this into consideration and introduce auto piecing system in the sliver to reduce the fault. So, here if there is any breakage, so it will create the, it will automatically piece the sliver. So, in auto piecing, in the manual piecing, what happened, we piece the sliver by overlapping. So, overlapping it creates the long thick fault, but auto piecing, which will actually ensure there is no such significant variation in mass per unit length. Missing slivers in draw frame during the this process can also lead to very long thin places. So, during at the creel we have to have better stop motion, so that the long thin places are eliminated. The effectiveness of the sliver stop motion should be looked into regularly, because sliver stop motion, if there is any breakage in sliver or missing sliver, it should stop immediately. The piecing practice of tenters need to be attended, otherwise if the piecing practice, that means joining of slivers are poor. So, that means here they will join with the higher thickness. So, that will create long thick places. Cramming of sliver in draw frame can also be source of the fault. The industry can increase the gap between the can and sliver so as to avoid the incidence of sliver rubbing against each other. So, what happened if the can placing are closer. So, in the creel side, so these slivers will rub each other and they are coming out at high speed. So, that will generate the fault. Reducing creel and web tension. So, web tension we can reduce by controlling the positive control in feed table, that we can do. Now, how to select the draw frame? Optimum degree of flexibility, preferably a single delivery machine for quality efficient draw frame system. Okay. So, preferably we should use the single delivery machine. Auto leveling system is required in the draw frame. Wide range of can size to have high productivity and saving space and material handling cost. Automation at different stages, stop, start, stop motion, different signaling system we should check. Environmental protection such as less noise and dust, these are the basic parameters before selecting the draw frame. We must take care of this. Central lubrication system which will reduce the wastage of lubricant and also reduce the maintenance time. So, we will stop this section at this point. So, next session we will discuss a new topic. So, till then, thank you.